BIMStorm Oklahoma City conclusion, November 9th, 2012. The College of Architecture of University of Oklahoma sponsored this DREAM course for the planning of Oklahoma City. Tammy McEwen and Lee Fithian's class was involved with this BIMStorm. My name is Kimon Onuma. We created the BIMStorms and we're from Onuma Inc. And Finance Jernigan, also the author of Big BIM, Little BIM, and Makers of the Environment, has been very involved with this BIMStorm. We had several months of preparation, training, and which was accelerated actually toward the middle of October. We had weekly sessions with webinars, and then a live session on November 7th, just a few days ago, at University of Oklahoma. And we had several other live sessions over the last few days collecting the input from the participants and the students. The City of Oklahoma City provided the GIS background layers, which were put on a server, and they were merged together with building information modeling in the Onuma system. This is a view of the GIS layers and building information model projects that you see toward the bottom in the quarter shore area. And this is some of the results from the last few days. This was literally assembled just even a few hours ago. Projects from various students. We're going to highlight a few of them here. Amber Conwell and Cole Hickson. This is the massing model of their project in the Onuma system and the Google Earth. And there's research and analysis. There's a lot of documents that were attached to the project. A lot of studies were done, massing studies, planning studies, and then more detailed models and renderings were prepared for the project. We are not that familiar directly with these projects. We haven't heard a presentation about them, so I'm not going to use this opportunity to present what the project's about. I'm just going to flip through some of the images to show you this particular project from this group of students. There are Revit models and renderings. The next project is from Eric Medina. Again, a massing model in the Onuma system, the detailed model in Revit and BIM. A lot of analysis, a lot of data prepared for each of these projects. Different views, 2D and 3D views, and background studies that were used as a basis for the planning. And the location of the site at Southwest 15th and Walker. And there was a lot of precedent studies going on as the designs were analyzed, and there was also the teams that collaborated together were doing cost estimates related to the project and constructability. We're just assuming this just looking at the material that was produced. Background demographic studies, household incomes, etc. A lot of the basis for how the design actually turned out. Energy studies and climate studies for the area, zoning information, and massing models. The next project is from Amy Schell and Cody Wheeler. Again, their resulting model, their massing model in the Onuma system and Google Earth. Their detailed building information models and renderings and plans. Color studies and elevations, and again a cost estimate based on uniformat for this project. There were also schedules created. Amy's team actually had a Microsoft project schedule that was imported to Ganter to be able to share it on the web so others can view it. Sketching, it was great to see freehand sketches attached to the projects to get the concept of how these were coming together. So it's not all about computer graphics, but the combination of freehand sketches, models, physical models, and computer models, bringing it all together for the project. Next project was from Kelsey Fitch, Rob Johnson, and Chris Kosey. Again, the resulting plan, this was not a single building, but a group of buildings in an area of the city to the east of the new Central Park. The basis for their concept and studies and analysis of the whole area. Again, energy studies were included. Design context, sketches and maps. analysis and calculations, photographs of the site, precedent studies of different projects that were used for inspiration, I believe, of the project, and hand sketches of adjacencies and how the rooms are going to be laid out and the adjacency matrix. The next project is from Sarah Halem and Mitch Wilson. Again, the resulting model in the ONUMA system, and the detailed model, I believe this possibly was done in Revit. We're not completely sure, but I believe it was a building information model in Revit with renderings and 2D plans and close-up views of the building. We had comments coming in from participants remotely. Michael Scarmack actually posted a comment of the axial relationship of the new park, north to south, core to shore, and possibly an east-west axis from Wheeler Park over to the east side of the shore. Balfour Beatty Construction presented some concepts of set-based design, having 3 schemes and jumping off to 96 different options and comparing contrasting the cost and energy for each of the schemes, using open standards such as COBE, and doing cost analysis and posting that result back using many different tools. The end result here that we're going to show, this was just compiled actually this morning. We're taking all of the projects that were submitted and merging them back into the city model. So each individual project obviously has a lot of effort and a lot of data and a lot of thought put into it. So now the scenario is, what if we can use this approach to mash this all together into a GIS BIM environment in the BIMStorm, and then being able to use that background data to be able to continue to do what if scenarios and what if planning, scenario planning with dates and cost and all the other factors that are involved in planning a project. So we'll show that live next. We want to thank everybody for being involved with this. There's a lot of other project members that were involved as well in the process, and we actually have it all posted on the web. There's several hundred images actually posted from the different teams that were involved, so you can view that at your leisure. This is a live view now in the ONUMA system. We just, in the last few hours, we merged in the resulting projects from all the teams. And this is the result of that. You actually see the GIS data in the background that came from the City of Oklahoma, City Planning Department, I believe. You can turn off the layers and actually start seeing the planning studies that were done by each of the teams, focusing in on this core to shore area here. And you see we actually took the buildings. There were several projects. The 5 that we highlighted are lined up here on the left side. Here's the main site that everybody was working on their projects. Amy Shell and Cody Wheeler's project is there. And you can see the other projects kind of lined up to the north of them. We just took the projects and kind of stacked them up to the north. So Eric Medina and Adam LaCours and Sarah Halem and Mitch Wilson. And then at the very top, Amber Conwell and Cole Hickson. And then we also lined up the other 20. We received about 20 submittals in the last 24 hours from the teams. We've seen a lot of this was for the first time we'd actually seen the project, so we're just learning about them as we open them up, and we place them on different sites to simulate what would happen if you actually had all the area built up here. The last team here actually had their project on the right side. This is one of the 5 projects here, and then we also have some prototypical buildings that are still left in here, residential projects, museums, and this is all theoretical. What if we actually plan this here? And there was another team, the FBS team, I believe, with their project here on the right side. So this is the result of seeing all of them together here. What you can, and they're color coded by different things. So this is OmniClass by use. We actually had another one with construction status, and so a lot of different scenarios can be planned here. The main point here is that this is not just only the graphics now. We actually imported the building information model, so we are able to do analysis with the results, do roll-ups, for example. So you could say, well, let's generate a site report of all these buildings, either aggregated all together or one building at a time, kind of a comparison type of a view, or export it out to Google Earth and view it in a different format, actually viewing it in 3D, which we'll look at next. So here's an aggregated view of all the buildings in the city plan. It's actually calculating them on the fly. We haven't adjusted any of the assumptions, but it's actually calculating the total estimated construction cost, which is running over into the 3 billion range if you take all of the buildings that are landed here. Um, the amount of square footage and net calculated area and the gross areas are being calculated here. Some of the buildings did not have all the spaces in it, so they were missing some square footage, but this is a first shot of getting all the buildings, merging them in together. So as we start working with the teams, we can start updating the square footage. The point here is that this is actually referenced back to their original design, so if they updated their design, it would actually update these charts. It's starting to calculate building occupancy and capacity, even some early energy analysis of utilities, how much energy is going to be used per year, and the projected operations and maintenance cost all aggregated together. And these pie charts here are actually color-coded by facility type. We quickly created a classification system, used OmniClass, to say what percentage and what square footage of residential, commercial, and recreational facilities are being planned. All of these charts are a dashboard that as the plans are updated, we would actually see a new result here. You can also run a comparison listing all the buildings together. It's a minute or so to run because there are a lot of buildings, but each of these vertical columns is a building on the master plan, and you can actually scroll and view different parts of the different buildings here as you start seeing them when they scroll over. So for example, if I go to the right here, each of these is a building. Each column is a building, all about 40 buildings or so, with some with images that were attached by the different teams. So these are being aggregated up from the teams that are actually submitting the buildings, and you see the individual energy use and operations and maintenance cost for each building. So this is a dashboard view in 2D, but now if we do an export and say let's export this out and look at it in 3D in Google Earth, we'll say we want to include time, a 4D time element, and we want to color code it by building volume and say category by OmniClass, and export this out with a white background as well so we can kind of see what's going on. So here we are in Google Earth now. In Google Earth we can also even turn on the 3D buildings that are available from Google of the downtown Oklahoma City. And we'll focus on this Quarter Shore area, the master planning area. It's a blank site because we're starting at 0 here, and we have a timeline. Each building was assigned a schedule, and each element even too, so we're showing in roads and the parcels coming in. These dates can all be easily changed, but you can start seeing the buildings coming in as we move the timeline over and hit the play button. We can actually let it just self-play here. And you see the buildings and the students' work. The work from Amy Shell and Cody, Eric and Adam LaCours, Eric Medina and Adam LaCours, Sarah Hillman and Mitch Wilson, Amber Conwell, Cole Hickson and Matthew Stouf, and the one more team here with their master planning buildings here on the east side. Each of these buildings again has data associated with it. So for example, if we go into a more close-up view of Amy's project, remember the detailed renderings we had earlier. These models are based on the same building information model that created the detailed renderings. The only difference here is that we really focused on the I, or the information of BIM. We wanted to see so each of these buildings actually has data associated with it. So when I click on this building by Amy Shell and Cody Wheeler, you can actually see the total square footage and some other information about construction schedules. The same thing with each of these other buildings, and you can fly around and even change the timeline and do different studies. So all of these, the dates for construction can be adjusted on the Onuma system side and then exported back out to do a quick what if again. What if we change the sequence of construction of different parts of the city? How is it going to affect the density and the marketability of units, and is it close to the park, and how are the roads going to be developed, etc. If you zoom out and actually look at the whole site, you can actually even do a roll up. If you click on the site itself, it actually starts to show you more information about kind of a roll-up of the entire area versus just a single building. So there's an aggregated view of how many acres, how many people, how many cars. Not all the buildings had cars and people assigned with it, so we're not actually getting a true count yet. But if each team actually updated their data, it would stream back in, and we'd get a new view of this, including the estimated energy use and water use for the whole area.